In this video, we are going to be going over logarithmic properties. So let's first cover the properties of logarithms. So the first four properties we already know from the previous section. So we have property 1, which says that log base a of 1 is going to equal 0, and by extension, the natural log of 1 is equal to 0. And this is because anything non-zero raised to the 0 power is equal to 1. And then our next property says that log base a of a is equal to 1, and by extension, the natural log of e is equal to 1, and this is because anything raised to the 1 is equal to itself. Then we have log base a of a to the r is equal to r, and by extension, the natural log of e to the r is equal to r, and this is because anything raised to the r is of course equal to itself raised to the r. We can consider this the power property of logarithms. And then next we have property 4. So this was the last property we saw in the previous section, which says that a to the log base a of x is equal to x, and e to the natural log of x is equal to x. So if we ever have a to the log with the same base, then what's ever inside the logarithm is going to be what that expression is equal to. And this is again because exponential functions and logarithmic functions with the same base are inverses of each other. Okay, so we can kind of think of this property 4 as like the inverse property. And then now we have our 3 new properties. So we have the product property for logarithms. So it says that the logarithm of the product is equal to the sum of the logarithms. In other words, log base a of x times y is equal to log base a of x plus log base a of y. Then we have the quotient property for logarithms, which says that the logarithm of the quotient is equal to the difference of the logarithms. In other words, log base a of x over y is equal to log base a of x minus log base a of y. And then lastly, we kind of have like a generalization of the power property. So for our last property, it says log base a of x to the r is equal to r times log base a of x. All right, and now let's get into our examples. So in these examples, we are going to be given an expression involving logarithms, and we are going to use the properties above to try to write the expression as a single logarithm with a leading coefficient of 1. All right, so for our first example, we're given log base a of x plus log base a of y minus log base a of m. So we can use the product and the quotient properties here. So let's use the product property first, and we can go ahead and combine log base a of x plus log base a of y as log base a of x times y. Again, this is according to property 5 above, the product property. And then we still have minus log base a of m. Okay, and then next we can use the quotient property to say that this is equal to log base a of x times y divided by m. Since we had minus log base a of m, that's the same as just dividing by m inside the logarithm. Right, and now we have the expression written as a single logarithm with a coefficient of 1. So we are done. On to the next example. So in example 2, we're given 2 times log base m of a minus 3 times log base m of b squared. Okay, so we are going to have to use the power property, property 7 here. So for 2 times log base m of a, that's going to be equal to log base m of a squared according to the power property. And then 3 times log base m of b squared is the same as log base m of b squared cubed. Okay, and then we can go ahead and use power of a power to simplify the exponent over here. So log base m of b squared cubed is the same as log base m of b to the 2 times 3, or in other words, b to the 6. Whenever we have power of a power, we just take the product of the powers, of course. And then now we can use the quotient property to say that this is equal to log base m of a squared over b to the 6. And again, now that we have the expression written as a single logarithm with a coefficient of 1, we are done. All right. Next, we have 3 times the natural log of 3 minus 1/2 times the natural log of 36. So again, to get rid of these coefficients out in front, we can use the power property. So we can say 3 times the natural log of 3 is equal to the natural log of 3 cubed minus, and then 1/2 times the natural log of 36 is the same as the natural log of 36 to the 1/2. Oop. Okay, then we can use the quotient property to say that this is equal to the natural log of 3 cubed over 36 to the 1/2, which by the way is the same as the square root of 36. And then we can go ahead and simplify. So we have natural log of 3 cubed is 27, and then square root of 36 is going to be 6. And then we can simplify even further, canceling out a factor of 3 from both 27 and 36. We can rewrite this as natural log of 9 over 2. All right. Next, we have 1/3 times log of 8 plus log of 5 minus 3 times log of 2. Of course, here, since we just have log, that means the base is 10. Not that it really matters much what the base is for these particular examples. So using the power property again first, just to get rid of these quotients, we can rewrite 1/3 times log of 8 as log of 8 to the 1/3 plus log of 5 minus, and then 3 times log of 2 we can rewrite as log of 2 cubed, or to the 3. All right, and how about we go ahead and kind of simplify things first before we start using the properties. So log of 8 to the 1/3 is the same as 8 to the cube root, which is going to be 2, because 2 cubed is of course 8, so 8 to the 1/3 is going to be 2. Then plus log of 5, and then minus, and then 2 cubed is again going to be 8, so minus log of 8. So now let's use the product property. So for log of 2 plus log of 5, we have log of 10, which by the way is technically going to be 1, minus log of 8, but we're just trying to write this as a single logarithm. So we could go ahead and write this as log of 10 over 8. Which we can reduce to log of 5 over 4. All right, now in the next examples, we're pretty much going to do the same thing that we just did, except in reverse. So now we're going to take some expression involving a logarithm and try to write it as a sum or difference of logarithms with all variables raised to the first power. Okay, so for our first example, we're given log base 2 of 6x divided by y. And so we can use the quotient property first to say that this is equal to log base 2 of 6x minus log base 2 of y. And then we can use the product property to rewrite log base 2 of 6x as log base 2 of 6 plus log base 2 of x minus log base 2 of y. And I would say as far as the instructions are concerned, we can be happy with our answer here, but I will point out that we could decompose log base 2 of 6 even further using the product property. We could write it as log base 2 of 2 plus log base 2 of 3, because of course 6 is equal to 2 times 3, and then plus log base 2 of x minus log base 2 of y. And of course, log base 2 of 2 is going to simplify to 1. So we would have like 1 plus log base 2 of 3 plus log base 2 of x minus log base 2 of y. So of course, if we were reading the instructions very literally, I would say that we could be happy with our answer right here. Though if we wanted to expand things as much as possible, we could get it all the way to this. So 1 plus log base 2 of 3 plus log base 2 of x minus log base 2 of y. Okay, next we have log base 5 of 5 times square root of 7 over 3. So again, we can use the quotient property first to say that this is equal to log base 5 of 5 times square root of 7, then minus log base 5 of 3. And then we can use the product property from here to break up 5 times square root of 7, or rather log base 5 of 5 times square root of 7 as log base 5 of 5 plus log base 5 of square root of 7, which by the way is the same as 7 to the 1/2. And then we still have log base 5, or minus log base 5 of 3. Okay, and then of course log base 5 of 5 is going to be 1, so this equals 1. And then we can use the power property for log base 5 of 7 to the 1/2 to rewrite that as plus 1/2 times log base 5 of 7, and then finally minus log base 5 of 3. All right, next we have log base m of the square root of 5 times r cubed over z to the 5. So what we can do first is we can remember that taking the square root is the same as raising something to the 1/2. So we can go ahead and say that this is equal to log base m of 5r cubed over z to the 5 to the 1/2. And then we can use the power property to say that this is equal to 1/2 times log base m of 5r cubed over z to the 5. Okay, and then from here we can use the quotient property first. So let's just leave the 1/2 factored outside, and then we'll worry about distributing that afterwards. So we're going to have 1/2, and then inside brackets or parentheses, log base m. So we're using the quotient property first, so we're going to have log base m of 5r cubed minus log base m of z to the 5. Okay, and then we can say this is equal to 1/2, and then now let's use the product property for log base m of 5r cubed. So this is equal to 1/2 times log base m of 5 plus log base m of r cubed minus log base m of z to the 5. Okay, and then now we can use the power property for log base m of r cubed and log base m of z to the 5. So we can write this as 1/2 times log base m of 5 plus 3 times log base m of r minus 5 log base m of z. And then we can go ahead and distribute the 1/2. So this is equal to 1/2 times log base m of 5 plus 3/2 log base m of r minus 5/2 log base m of z. All right. Now for the last of these examples, we have log base 2 of a times b over c times d. So the first thing we can do here is use the quotient property to rewrite this as log base 2 of a times b minus log base 2 of c times d. And then we can use the product property on each of the two terms that we have here. We want to be careful to distribute the minus, though, over the two terms that we're going to get when we use the product property on log base 2 of c times d. So we're going to have log base 2 of a plus log base 2 of b and then minus, and we'll start parentheses or brackets, log base 2 of c plus log base 2 of d. Okay, and then from here we just distribute the minus, so we have log base 2 of a plus log base 2 of b minus log base 2 of c minus log base 2 of d.